Alright, so now we're at least going to get started with setting up a simple linear regression example. The first thing that we need to make sure we have is scikit-learn, pandas, and quandl. So open up terminal, command prompt, whatever, and pip install sklearn, pip install quandl, and pip install pandas. And once you have all of those, you're good to go. So to install those, go ahead and pause the video and pick back up once you have them. Okay, so once you have those, let's go ahead and get started with a simple example. So we're starting with regression, and the idea of regression is to take continuous data and figure out a best fit line to that data. And basically what that just boils down to is you're trying to model your data, and the way that we do that with regression is with at least simple linear regression is with just a straight line. So the equation of a line, as we'll talk about more down the line, but as you might remember from school, y equals mx plus b. So if you have x, you can figure out what y is, also if you have m and b, right? So basically the whole point of regression is to find out what m and b is, okay? So for example, a lot of people use regression with stock prices, so that's what we're going to do, at least in this one. And so the idea is this is continuous data, right? So you've got, let's say months and months of stock prices, and each price is its own kind of unique day, but all the data is kind of one data set together, as opposed to like with classification, where each group of data has its own unique label. So with machine learning, basically everything boils down, at least with supervised machine learning, everything boils down to features and labels. And features are like your attributes, or in this case, the continuous data. So let's go ahead and get started, and then we'll talk a little bit more about features. So first of all, let's go ahead and import pandas as PD, and then we're going to import quandl with a capital Q. And then what we're going to say is the df for data frame equals quandl.get, and we'll put in the ticker. You can get these from Quandl, so if you just go to quandl.com, you can use a little search and find stuff. Like if I said Google stock, we can probably find it. And let's see, I'm trying to find, we're using the wiki data set. Let's just do free. Anyway, when you find it, you can find all kinds of different data sets here, but we're looking just simply for the wiki one. I'm not finding it. I'm not going to, oh wait, here it is. Let's see. Maybe this will be it. Anyway, so you'll pick a data set, and you can come over here, and you can either just download, or more importantly, here's the quandl code. And then you could click on like Python, and this is the exact statement to get it. If you have an account, you can make basically unlimited requests to free data. If you don't use an account, like we're not going to use an account here, and we're not going to use like an auth token. If you don't have an account, I think it's limited to like 50 calls a day. We're actually really only using Quandl fairly short term here, and then maybe later on, but so you really don't need to create an account. But if you like Quandl, you might as well make an account at some point. So anyways, quandl.get, and then wiki/Google was the ticker there. So then we can just simply print, let's print the df.head just so we can see what it is we're working with. And we'll see that basically each column here is a feature. So open, high, low, close. These are features. So in machine learning, you can have all the features you want, but you want to have meaningful features, right? Features that actually have something to do with your data. So some people are pretty avid believers in the idea of like pattern recognition with stock prices, okay? And that might be you. But do you need every single one of these open, high, low, close columns to do pattern recognition? No, right? Also, like you'll note, we've got open, high, low, close volume, and then adjusted. And adjusted is adjusted after things like stock splits. So a stock split, maybe you're a company, you have 10 stocks, and each stock is $1,000 a share, and you decide, I want my people to be able to buy shares of my company for less than $1,000. So you might say, okay, bam, every share is now 2 shares, so we have 20 total shares, and the share price is $500. Okay, so you have adjusted prices to like account for that, so it doesn't look like price went from $1,000 to $500. So that's what adjusted is. So we're going to be using those, but again, each one of these is really related to the other one. Like the correlation of these two columns is super high, right? So would you use each of these columns? Does like the next one really bring that much meaningful data? No, but one thing to always think about when you have features and labels is maybe like, what about the relationship between those columns? So when we get into something like deep learning and then some of the other algorithms, you can start to discover relationships between attributes, but with regression, just simply no. Right. So what you want to do is you want to like simplify your data as much as possible. So you want as many meaningful features as you can get, but useless features, as we'll show kind of through the series, can really cause a lot of trouble for your machine learning classifiers, especially the more simple ones and supervised learning and so on. So anyways, we'll close out of this and let's go ahead and grab some features. So what we're going to say first is we're going to kind of pare this down. We're just going to say data frame equals the df, and then we are going to create a long list basically of all of the columns that we want to have. So we're going to take adjusted open, and then I'm just going to go ahead and copy this. Copy. Okay, so that's adjusted open, and then we're going to take open, so high, low, close, and volume. Okay, so now we have just these columns. So we just kind of recreated our data frame to just be the open, high, low, close, and volume of the adjusted ones. So then, like I was saying, some of these columns are relatively worthless, but they do have some relationships. So for example, like what is interesting about high and low is it's the margin of high and low tells us a little bit about volatility for the day. Also, the open price, that's the starting price for the day, and its relationship to the close price tells us, did the price go up? If so, by how much? And did it go down? If so, by how much? And so on. So the relationship there is very valuable, but a simple linear regression is not going to seek out that relationship. It's just going to work with whatever features you feed through it. So what we need to do is define those special relationships and then use those as our features rather than redundant almost prices that aren't going to really give us anything else very useful. So first let's do the high minus the low percent. So this is like the percent volatility almost. So we're going to define a new column. We're going to call it HL underscore percent. And then that is going to be, I'm having a hard time here. That's going to be equal to, so percent change is just, in this case, it'll be the high minus the low divided by the low times 100. So for us, it'll be df 80j high minus the df 80j close. And what's happening here is just on a per row basis. It just does this column minus this column. So that column divided by df adjusted close. Whoops. And then times 100. You can either times it by 100 or not. The classifier really is not going to care about that. We're just doing that for ourselves. Okay, so that's the high minus low percent. And then now we actually want just like the daily percent change, like the daily move. So I'm just going to copy that whole line, paste. And then we're going to call this one percent underscore change. And that is equal to pretty much the same thing, only we're going to change some stuff. So this one is, so normally percent change is new minus the old divided by the old times 100. So that would be adjusted close minus adjusted open. So new minus the old divided by the old times 100. Or I'm sorry, we did the wrong way. So yeah, new minus the old divided by the old. So this will be open times 100. So that's percent change. Actually, I mean, you could have close here, and again, the classifier doesn't really care as long as everything's kind of normalized. But yeah, so this is either way would have been fine, but this is the actual way you should do it anyways. So once we have that data, we're going to define a new data frame, and we're instead going to say, so it's going to be df equals df brackets, and then now we define the only columns that we really actually care about. And so in our case, the columns that we care about is going to be adjusted close, the high-low percent, the percent change, and then volume is also somewhat useful to have. Okay, so volume is just, how many trades were occurred basically that day. So volume also is kind of related to volatility. So you could also make more features with some sort of relationship there, but we'll try to keep this pretty simple. So for now, we'll just print df.head. And we'll wait just to make sure everything worked out, and sure enough it did. So we have all the numbers that we're kind of interested in. So we've got our features, and eventually this will actually wind up being possibly our label, but we'll get to, I guess think about before now in the next tutorial, right? Features are the kind of attributes that make up the label, and the label is hopefully some sort of prediction into the future. So will the adjusted close, will this column actually be a feature, or will it be a label as it stands right now? So think about that, and in the next tutorial we'll pick it up and start getting closer to actually making real predictions with this data. So if you have any questions, comments, whatever, leave them below. Otherwise, as always, thanks for watching. Thanks for all the support, subscriptions, and until next time.